All right. I hope that we have everyone here again, or at least the people that are not going to be watching into space in the back. Our next speaker is actually was my co-presenter from last year. And I was actually wondering coming in here which gimmick we were going to get during this talk, but I think I've already seen it now. So here to talk about compression dictionaries is Robin Marx.
Greetings, mortals. My name is Vlad Dracula, and I am here today because the web has a weight problem. In the past 10 years, mobile pages have nearly doubled in size. Now, of course, we vampires have figured out how to deal with size issues centuries ago. When confronted with them, we simply transform into a bat, and so we can fit into even the tiniest of holes. This is why 2 years ago, these two excellent gentlemen reached out to me to see if we could bring some of this vampire technology to the World Wide Web. And this eventually became Compression Dictionary Transport. I, of course, had originally suggested a different name. Sadly, I was overruled, but still, the resulting technology is still quite impressive. Because what this allows us to do is to compress files relative to other files. And two main ways of doing this. First, delta compression. Let's say you have a version 2 of a file. You can compress this relative to its previous version, version 1. And what you get out of there is basically only what has changed in version 2, which should, of course, be much smaller than the entire file. The second mode is shared, where you will reuse a single dictionary across multiple resources. For example, let's say you have HTML templates used on all your product detail pages. You can put them in one dictionary, and then every page compresses relative to that, and you get output only the content of that page for the product, not the entire HTML thing. The way this works technically is with a few headers. The server can send back a use as dictionary HTTP response header if the browser is fetching something that can be used as a dictionary, and it's going to use match targets, basically wildcard URLs, to indicate for which paths this thing can be used to compress. The browser then stores that in the cache, and if it still has it in the cache when it's requesting one of the things that match the paths, it will send an available dictionary request header, letting the server know, hey, I still have this thing in my cache. You can compress relative to this dictionary if you want. The final thing we need is a new link type header, because the shared dictionaries are basically new files that you don't normally use in a normal web page. So we need some way to tell the browser that they are available as well, and that is with this new thing. Relatively simple setup, very impressive results. Initial results from Patrick Meenan show up to 96% reduction in size. Google is actually deploying this into production right now. On the search page, they get up to 50% smaller pages and 9% LCP improvements on Google search. Okay, very impressive. At Akamai, we have been trying this out with several customers, seeing also impressive results. Interestingly, for example, our 94% on the right there, turns out that was a customer who was inlining critical JavaScript and CSS on every page. Of course, if you extract that into a dictionary, the actual page goes way down. We also have some customers experimenting with this themselves. One that has a very large single-page app who is able to reduce their bundle sizes by over 1 megabyte by doing this. Of course, very good. And then we have one of our e-commerce customers, not quite the 90% reduction, but they were already very happy with the 40% as well. Now, promising results. However, as my good friend Dr. Frankenstein always says, Frankenstein always says, a body is not built in a day. And this also goes for HTTP response bodies, of course. Because it is not trivial to actually get this compression going. There are, as far as I know, no off-the-shelf servers or frameworks that actually have this built in. right now. And you could conceivably do this yourself, but it is somewhat tricky. You, for example, can't just use a compression library directly because every dictionary needs like a magic header value up front. And it turns out in practice it can be quite annoying to match dictionaries to the proper things that the browser have cached, especially if you're iterating on the implementation. And if you get it wrong, it goes wrong really badly. Ask me how I know, okay? Because if you're compressing all your HTML and you make a mistake and the browser can't decompress your HTML, your entire site goes down. Okay, and you wouldn't even know that that happens because you wouldn't see run beacons coming in because your entire site is down. And usually you would rely on network error logging, a browser feature that normally bypasses that, but it turns out it's not exactly clear how well this works for decompression dictionary situation. Okay. So what we of course recommend, as always, if you want to do this, use a CDN. All the big CDNs have a way of doing this. They all use WebAssembly through their edge computing platforms workers, where you can actually do the actual compression, the dictionary compression, quite easily in that way. So we can definitely do that, but that's just one step of the problem, getting the things compressed. The bigger problem, at least in my experience, is actually defining those dictionaries, creating the dictionaries and knowing what to put in them. Especially what I am trying to do at Akamai, I'm trying to make a transparent proxy that does this automatically for all traffic going through our edge, while it automatically learns which dictionaries should be created and to which resources they should be applied. As you can imagine, that is not at all easy to do. But even if you're not trying the hard mode like I am, and you have full control over the origin, and you know what your resources are doing, even then you can run into some serious issues. For example, for the delta compression, a lot of JavaScript bundlers are not deterministic. It's not that you will always get the same input files that get bundled into the same output bundle. Okay? And even if you have that, we found out that other tools, like minifiers, are also not always stable or deterministic. So they will shorten variable and function names to shorter versions. But if they don't do this consistently across builds, you will end up with different names for everything between versions. And that will, of course, mess with the efficiency of the dictionary compression because that basically does string matching internally. So we had one customer that actually had to go through a lot of trouble to manually define rename maps for their minifiers to get optimal performance out of this. We then also have things like multiple active versions. It's not always version 2 versus version 1. Some customers have 20 versions in production at the same time. You can also imagine someone doing A/B testing, having 2 valid versions at the same time. So the question then becomes, what do you compress relative to what? The easiest way would be to say, okay, whatever is the base version at the start of the day, we keep using that for the entire 24 hours. But is that actually the most optimal that we can do? Maybe we should also do something like compressing version 4 relative to version 2 instead of just version 1, okay? And it is not super obvious what the best approach is there. And the more of these variants that you will create, of course, the more compute you will need. And the more you're going to be fragmenting your cache because you're generating more variants of this. So it's quite difficult to know what the optimal approach is. And especially if you're doing the transparent proxy like I am, you might not even have easy context, okay? These are normal versioned URLs. How am I supposed to know which is version 1 and which is version 2, or which are related to each other, okay? And that's actually the easy thing. That's delta compression. That is somewhat okay. If you start looking at shared dictionaries, it really goes off the rail, okay? Ideally, what I would just like to do, easy for me, is just take all your JavaScript, CSS, and HTML all in one big file and just use that for everything. But if you do that, of course, you end up with a very, very large multi-megabyte file. And because shared compression dictionaries need to be downloaded separately by the browser, they're not normal things for the website, they ideally stay as small as possible there as well. So there are ways of getting that size totally a little bit down, but those are again a bit more complex. So ideally, I don't want just one shared dictionary, I want several. But then you start getting the question, how do I actually shard? Do I create a different dictionary per resource type? Or do I create a different one per page type, per type of page that I'm deploying? Okay? And again, if you have full control over the origin, that is going to be easier. If you have my situation, where you have to figure it out yourself, it can be very difficult. Just last week, I had a customer who had 3 different stacks on their webpage. The homepage was something custom, the categories were Angular, and the product detail pages were Next.js. How am I supposed to figure out what the optimal dictionaries are, okay? Well, you mortals keep asking why we vampires want to kill you all. Well, you have your answer, okay? So, I'm not going to claim today that I have all the answers, but this is where I got at this point in time. So, I decided to give up on the dream of automatically figuring out what belongs together. That is just, I don't think, doable, unless with a very complex machine learning model maybe. So I am asking now that our customers would give me minimum configuration, okay? At least give me those paths, those wildcard paths, that at least they tell me which things kind of belong together and which things are conceptually, can be in the same dictionary. Because those are the most difficult ones to figure out in my experience. Once I have that, I will then use telemetry, so server logs, run beacons, whatever you want, to kind of look at which are the most popular resources that match the URLs on top. Because those are, of course, going to be requested most often and benefit most from potential dictionary compression. I try to figure out who those are and then generate dictionaries based on that on the fly. I then do the WebAssembly compression once. So I fetch the normal version from the origin, compress it relative to the compression dictionary once at the edge, and then that gets stored in the CDN cache based on the used dictionary ID. This seems to work relatively well. There are some edge cases, but it seems okay. And I actually was surprised to find out, I talked to some of the SpeedKit guys today, we also saw before. They have this, as one of the only companies that I know of, have a full pipeline for this working in production, and they do something very similar. They are even more complex, or I would say advanced than this, but the basic concept is quite similar. What I'm trying to say is, it's early days. I don't think anybody has fully figured this out yet. It's easy to do dictionary compression and get a result. It's still very difficult to figure out what is the optimal result and where are the trade-offs that we need to make. So if any of you have experience or even just an opinion on what that should be, please come talk to me after this or tomorrow during the conference, of course. And I wanted to end with a very positive note because I don't think it has been announced yet, but since last week, compression dictionaries are in Firefox nightly. Yes. And just today, Pat was telling me that even Safari apparently has a pretty advanced implementation as well. So this is hopefully coming cross-browser very soon. So there is no better time than the present to start getting into compression dictionaries, because only together can we make sure that the web evolves from this back into this. Thank you.